Hi everyone, this is the second video for section 8.2 on adding and subtracting integers. So in the last video, we had just finished talking about sign models using integer counters, and now we're going to start talking about a number line using a number line with integers on it. So if we have a number line model, we're just going to start at the integer that's the first integer in our operation. So whether we're adding or subtracting things, we're just going to start at that number. And then every time we encounter a plus sign or a positive sign or a positive number, that just means to move in the direction that we're already facing. And if we encounter a minus sign, a negative, let me think of how to say this, a minus sign or a negative number, that tells us to turn around and move the opposite direction instead of the direction we're currently facing. And so this just essentially makes addition and subtraction of integers just boil down to moving along a number line, going back and forth. Okay, so we're going to do the same two problems that we did when we were using our sign models. So we want to use a number line, and we are going to look at -4, -3, -2, -1, 0, 1, 2. I'm going to extend this a little. Then we go to 3 and 4. Okay, so the first step, if we're using a number line model, is to draw the number line. So step 1 is to draw the number line. Okay, so remember in this number line model that we want to start at the first integer we have in our problem. So that tells us that our starting point is here at -3. And we're always going to start facing the positive direction. So I think I didn't give myself enough space here. So I think I need to redraw this number line. So step 1 again, draw the number line. Okay, so we're going to start here at -3, and we're going to start facing right. So we start here. And the book and I am going to choose to represent this as we always truly do start at 0 whenever we're using number line models. So I'm just going to say that first I go from 0. Our default starting point is always going to be 0, and then I go to -3, and then I turn back to face the right. So facing right is just saying that we're going to face the positive side of the number line. So you're facing so that you want to go in the positive direction. Okay, so in my problem I have here, I'm doing -3, and then I'm adding 4. So I've already gotten to -3. And so now I want to add 4. So because I have a plus sign and 4 is positive, both of those things tell me I move in the direction that I'm facing. So the plus sign says move right. The positive 4 reinforces that I need to move right. So I need to move 4 units to the right. So I am at this -3 facing right. So I go 1, 2, 3, 4. So I go 4 units to the right, and I end up here at 1. So what did we do? We drew our number line. I'm also going to move this a little to the side so I have more room. So what was the first thing that we did? We draw a number line. The second thing we do is we start at -3. So we go from 0, our default starting point, over to -3. And then since we add a positive, we don't change directions, right? There's nothing in this that tells us to change directions. And then we add our 4. So we move 4 units to the right. And then lastly, we are going to end at 1. So that tells us that 1 here is our answer. So this also tells us that -3 plus 4 is 1. So you can see that this is just going back and forth on a number line. It's going from 0 to -3 and then going 4 units to the right. And so you can really think of this, these problems as, since we went from 0 to -3, this is really subtracting 3 and then adding 4. So again, this helps move us closer and closer to saying that 4 minus 3 is 1, because when we go from 0 to -3, we go 3 units to the left, which is like subtracting 3 units, and then we move 4 units to the right, which is adding 3 units. So you can think about this in either of these ways. So we're just kind of building up to why we can do this equivalence. Okay, so that's how we modeled an addition problem on a number line. So now we'll model a subtraction problem. Okay, so again, we start with drawing our number line. -3, -2, -1, 0, 1, 2, 3, 4, and I'm going to extend it more. So an advantage that you all have when doing this is you know what these answers are supposed to be. And so you know how, again, I give myself enough space on top. So you know how +7. So whenever you're drawing your number line, you should know exactly how long to make it, right? So you should know just by whenever you're given this problem that you're going to have a number line that goes at least to 7 on the positive side. Okay, so we drew our number line, and then what do we do? So we want to get at our starting point. So we draw our number line and start at 4. So first things first, we go from 0. Oh, my apologies. So we go from 0, and then we go over to 4. Okay, so we draw our number line, and we go from 0 over to 4. And then we see what our problem tells us to do next. So right after the 4, we have a negative sign, and that negative sign is going to tell us that we turn around. So did I say negative sign? I meant minus sign. So the minus sign tells us to face left, to turn from the right. Remember that anytime we start this problem, so once we get to our starting place, we're always facing right, facing the positive direction. And so the minus sign tells us to face left. And then what are we subtracting? We are subtracting a -3. So because we encounter a negative, we say that the negative sign tells us to face right. So you may see here in this First step, starting at 4, facing right. Okay. So we draw a number line and start at 4, facing right. We encounter first the minus sign, which tells us to face left. And then we encounter a negative sign, which tells us to face right. And then we encounter the 3. So now that we're facing right, we move 3 units in that direction. One, 2, 3. So now that we've accounted for all of our switching places or switching directions that we're facing, we move 3 units. And when we move 3 units, we end at 7. Right, we ended here at 7. So this tells us that 4 minus -3 is 7. And again, remember that these models are trying to help us, well, understand what's going on here, but they are also used as motivation to say why we can essentially cancel out negative signs and minus signs. And so again, you can see why this reinforces that. It's because each time we encounter a minus sign or a negative sign, we change directions. So whenever you encounter 2 of them in a row, like we did in this problem, you're just turning around twice and ending up facing the same direction that you started. And you can see that this is a motivation of why they just cancel out. Okay, however, we're not going to do that whenever you're dealing with these models. So remember, I know that you can add these numbers. And the point of these examples and these problems whenever you're tested on them is to show that you can do these models. And for students, when you first introduce these operations, it's not obvious that you can change subtraction to addition. And so we're just going to go slowly and just do the problems as they're written a lot of the time, because that's exactly how students will read them, is just how they're written. And we know all of these tricks just from doing mathematics for years. And I don't know if you realize a lot of the ways that we solve things are just using tricks. And you don't often think about these properties and all of these things that you've learned throughout this course. You don't think about these things whenever you solve problems in math because we've just done them for so many years. But at some point, someone had to teach you all of these tricks that we're so used to doing. And so we're just kind of, one of the main purposes of this class is to just kind of remind you of someone taught you these things, and this is how it went whenever you were taught it. Okay, so that's going to be all for the number line models, and that's all for this video.